Hello guys, welcome back to today's video. So in our last video we learned how to assign our dead and live loads, and we learned how to do that perfectly. But as I was running my analysis, we could find out that my live load wasn't applied, so I'm going to do that now. So dead load of 3 kilonewton per meter square, and let me replace this. So apply, then live load of 2 kilonewton per meter, then apply. So I have to select previous select and apply. Okay, so now if I run the analysis and show the reactions at the base, I'll get the dead load and the live loads, and that's it. So simple. So in today's video we are going to do something really special, and we are going to learn how to just assign or define our Seismic load in our Etabs app, and it's very interesting. Seismic loading, Seismic load is very interesting. It's very nice too. So just get ready for that, and don't forget to like today's video and also the previous ones, and subscribe to my channel, as it helps us to know that we are also engaging and we are creating content that you guys also like. And also, if there's anything you want me to know or anything you want to talk about the video, just leave it in the comment section and we'll interact. So let's get into today's video. So as I said earlier, we are going to assign our Seismic load, and for the Seismic load, it's not really a default in the Etabs app like the dead load and the live load that we already had them there. We have to define the load. We have to define them. So for us to define the load, we have to come here. So define, and we have load pattern. So you go to define, then come to load pattern. So when it comes to load pattern, you can see that we already have our dead load and our live load already there. So now we have to add our own loads. So we have to add our earthquake load. So let's add our earthquake load. But we know that for earthquake load, it's not just it happens in directions. So we have the earthquake load that is going to occur in the x direction, the y direction, the z direction. So we are not just going to create one, as in for one earthquake. We are going to create it for in the x direction and also in the y direction. So eq x, let's represent this like earthquake in the x direction. So that's the name we are going to give for the seismic load in the x direction. And the type of the load, we are going to click here and just scroll down. You will see seismic. So is this seismic we are talking about, not seismic drift. So seismic and the self-weight model, you don't have to change anything, it's already inputted into the app. Then auto lateral load. So for here, this is where you pick the code you'll be using to define your earthquake load. But when we're starting our design, we've been using BS code. But when we look through, we don't have any British standard code here that we can use to define our seismic load. So for here, you are allowed to pick a different code to just define your earthquake load. So for me, I prefer to use the Indian standard, the IS code. Some also use the Euro code 8. So depending on you, whichever you feel comfortable with, you can just choose. So if it's a Euro code you're using, you just have to select Euro code and just add new load. But in today's video, I'm going to be using the Indian standard, that the IS 1893. I'm going to use this for defining my load. So Indian standard. So once I'm done setting everything, I'm going to add new load. So now the earthquake load has been added, but after adding this load, we have to modify this lateral load. And we know that seismic and also wind load, they are all lateral loads. So we have to modify this lateral load. So we come here and modify. I'm sure by now you are very much confused. As like when I was also doing starting with this, I was very confused when I got to this part. But I'm going to take you through each and every part of this, and you are going to be okay after the explanation. So looking through, we have seismic zone factor, we have site type, importance factor, reduction, response reduction. I'm going to take you through every one of these. So first of all, we know that we are doing it in the X direction, so we are going to untick all the Y, and also let's take this one also out. So we are going to just take these out, and let's come here, seismic zone factor, that's the Z. Let me take you to one work I did. So we have here seismic load calculation, and it's according to the IS 1893. So this is the code I use for this seismic load calculation, and this is the formula that I use. So this is the formula here, and we have Z. So the AH is the horizontal acceleration, and we have Z here. That's the Z we saw in the Etabs app. So Z is the zone factor. So for the zone factor, according to the location where you are doing your design, so the location where the building will be constructed, you just pick the zone factor for that location. So we all know that, like, for a place like Ghana and some of the various countries, we don't have these areas are not really like earthquake prone areas, so we don't really have set those values that are also in the code. So sometimes the very least you can do is take a city that has the same spatial acceleration as that of Ghana. So let's say 0.25 G, if that's the value, so 0.25 G. You pick a city that has the same spatial acceleration as that. So I picked a location, and the location, this is the location. I can't really mention the name here. So I'm a Etabs, yeah, I'm very sorry, but I can't really mention the name right. But it has the same spatial acceleration as that of Ghana. So I'm going to pick this location. So when I pick the location, I'm going to take certain parameters from this location, as in like the zone factor. So for the zone factor for this location is 3, and for 3 the value that is associated to this is 0.16. So let's go back to our app. So per code, you can find all of those in the code, but I don't really want to be just going through the code. That's why I have this PDF to just take you through. So we have per code here, and zone factor Z, it was 0.16. So let's look for that here. So we have 0.16 over here. So we pick this one, so 0.16. Then let's come to site type. So for the site type, it's actually done according to the soil at the site. So the nature, so based on the nature of the soil, you pick the site type. So we have site type I, and III. Site type I is for hard rock, type 2 is for medium soil, and type 3 is for soft soil. So based on this soil, nature of soil at the sites you are just constructing, just pick, but mostly construction is being done in medium soil. But just in case that's not the situation where you are working, you just have to change it. It's very simple as that. So that's it for the site type. And we also have the importance factor. So the importance factor, it is a multiplier that we just apply to the design seismic force to account for the consequences of failure. So we used to ensure that the structure have higher importance, or like structures that will have like higher importance or are designed to resist greater seismic forces. So based on the importance or the use of the structure, every structure has its own importance factor. So for structures like hospitals, schools, power plants, and all those, you can use an importance factor of 1.5. For those that are like commercial or industrial structures, you can use 1.2, and for ordinary buildings you can use 1. So let's say our building is an ordinary building, so we are going to use the 1 value. So you can find all of them in the So I had my zone factor. This is the importance factor. Here I used 1.5 because I was working with I think it was a hospital, yeah. So I had to use the 1.5 for the hospital. So based on the importance or what the building will be used for, you just pick the importance factor. And we also have a reduction factor and response reduction factor. So for this, like, it reduces the elastic seismic force to a level that can be used for design. So the value of the response reduction factor depends on like structural system and the ductility of the structure. So let's go back here. For here I used 5. So we've now specified the zone factor, the site type, the importance factor to be 1, and we have response reduction. So for the response reduction, for special moment resisting frames we use the 5 value. For ordinary moment resisting frames we use 3. For steel structures we can use like 3 to 4, and for load bearing masonry we use 2.5. So for mine it's a special moment resisting frame, so I'm going to stick with this value here, 5. And with our top story, our last one is 5 and our bottom is the base. And also with the time period, I'm going to let the program calculate it for me, so I'm going to leave it as program calculated. But if you want to input your own time period, you can also do that with the user defined, but I'm going to leave it for the program to just do that for me. So program calculated. So now I'm done filling each and every section I'm supposed to fill for this seismic data. So once I'm done, I can just click on OK. And as I said earlier, the earthquake doesn't really happen in just one direction, in the X and also in the Y. So I'm going to add a copy of this. So this is it. So Y. So I'm going to change this just to Y. Seismic. I'm going to use this code too, and I'm going to add new load. So add new load, and I have the Y over here, so I can just modify lateral load. So I'm going to modify this. So I'm going to untick all the X just like I did for the, so I can just leave the Y. And per code it was 0.16 based on the zone factor with the city we chose. But if your city is in the IS code, you just pick the zone factor that's there and just use it for everything. So it's a medium soil, so II. Importance factor was 1. Program calculated. Response reduction, so 5. Everything is done. Just click on OK. So now we are done with the earthquake load, and we are done defining the earthquake load. So once you are done, you can just click on OK. So if you want to run an analysis including the earthquake load, you have to create a load combination. You see, in the normal load combination we normally do, maybe like according to the BS, maybe 1.4 times dead plus 1.6 times live. We don't really include earthquake load when we are doing that in your normal classrooms and stuff, but when you design of such tall structures or high rises or such things, you have to include your earthquake. So for that you can also, so we have load combination over here. So load combination. Now with our combination, we don't really have any combination here, so we can add new combo. So you can just add your new combo. So for this, you are the one going to specify, this is what I want 1.4 dead, 1.6 live. You can just specify all of that, but let's go with the defaults. So our default design combos, and it's a concrete frame design we are working on. So you check this box, concrete frame design, and check this one to convert to user combination editable. So for this one, you can edit the factors to suit what you want. So let's check this and OK. So these are the various combinations that the software gave me. So look at the first combo. I have 1.4 times dead. The second one, I have 1.4 dead plus 1.6 live. Third, I have 1.2 dead, 1.2 live, 1.2 earthquake in the X direction. I have all of these, and I can just continue just with one combo. So I'm done creating the combo, and I can just click on OK. But one thing you should take note is that the earthquake doesn't only happen in the x direction, as in just in this direction, but also in the opposite x direction. That means the positive and also the negative. So for the value we have for the x direction, you can also just just make it negate, can negate them and also get another x direction. So we can just come to load cases. We have our earthquake here, so you can just double click on that. So let's come here. So here, just look at the factor. So the factor here is scale factor is 1. So for us to just create another earthquake in the x direction, that is in the opposite x, we can just create a copy of this and negate this one value. So let's do that right now. So I can just put it here and add copy of case. So add copy of case. So ex negative, and I'll just negate the scale factor. So negative 1. Then OK. Then the y, so I'm going to do the same for y. So add copy of case. So I'm going to change the name to ey minus and also negative 1. Then click on OK. So now we have the earthquake load in the x and opposite x, y, and also in the opposite y. So we have all these. So you can click on OK. You can go back to your load combination. Since we didn't really create that, you can just delete this combo. So add design combo. So this one we are going to include the opposite direction. So concrete frame convert. So OK. So you see the load combination has become many than the first one we created. So the load combination are many over here. So once you are done, you just click on OK. So now you can just run your analysis again, and this time when you are checking for the reactions, you can check them according to the combos that you've created. So let's run the analysis for this structure. So run analysis. So the analysis is taking place. It's going to take quite a while, but if your machine is a very good machine, it's going to do that very fast. And now it's done. So now I can just look at the reactions at the bottom. So we have combo over here. So we have dead low. You can just check for the dead. So apply. You have the reactions. You also have live, and we have the load go into the foundation for the live, and also so for the x you also have to check this one. So let's check all the x and y. So apply. You get the force of the earthquake in the x and also in the various directions. So let's go to the combo. So with the combo, it's going to give you a combination. So our first combo was just dead load 1.4 times dead 1.5. So let's check with this one. Maybe let's go with combo 8. Combo 8, and yes, apply. Okay, so that's it for combo 8. I don't really know the cases it's taking. Maybe the plus the scale factor, maybe 1.2 there, 1.2 live, 1.2 earthquake. So that's it for the combo. So you can create your own combo and just run the analysis according to that combo, and you are going to get your reactions, the earthquake loads, the dead and also the live load. So you can just click on OK. I can just show on the form shape, and I'm going to have all of these. So for this, you can also check the shear force and movement, axial forces in this structure and everything. So in our next video, we are going to just talk more about our wind load, how to also assign wind load to our structure. So now we are done with the Seismic. So as I said earlier, based on the code you are comfortable with, whether Euro code, Indian code, whatever code you are comfortable with, you just use that one. But in this video, I use the IS code. So if you want to use a different code, feel free to do so. So that's it for today's video. Thank you.